So finally, we are entering the section of quadratic equations, right? So we'll be first looking at quadratic equations with real coefficients, and then a very small module on complex coefficients. So we already know that f of x can be a polynomial, which is basically denoted as a naught plus a1x plus so on plus an x power n, right? Now, if my n is equal to 2, that means that if the degree of the polynomial is 2, then I can represent it as a naught plus a1x plus a2x square. Everything above your a2 is 0. In other way, I can also write this as ax square plus bx plus c, where your a naught is your a2 is a, a1 is b, and a naught is c. Now, this is a quadratic expression. If I equate this expression to 0, then it's a quadratic equation. Remember, a shouldn't be equal to 0. If your a is equal to 0, then it won't be a quadratic equation. It will be a quadratic equation only if your a is not equal to 0, and this is a very important step. It's really neglected in a lot of places. So this is how it goes. Now, because this is an equation, this equation has roots, right? Roots in the sense those values of x which will satisfy this equation. So because it's a quadratic equation with degree 2, the maximum number of roots that it can have is 2. Remember, if f of x is a polynomial of degree n, then it can have at max n roots. Then, or rather I should say, f of x equal to 0 at max can have n roots. So if f of x is of degree n, f of x equal to 0 at max can have n roots. So here this f of x, ax plus bx plus c, is of degree 2. So f of x equal to 0 at max can have 2 roots. So this is at max, right? It can have 0, 1 or 2. Now the thing is, your ABC are real here. Remember, ABC are real because I'm dealing with quadratic equations with real coefficients. The roots are given by this formula. So this is the quadratic formula. You would already know this in your 10th. Minus b plus or minus under root b square minus 4ac by 2a. Of course, this quantity b square minus 4ac is known as your discriminant d, b square minus 4ac. If your d is less than 0, then you'll have the roots. So remember, there are how many roots are there in this formula? 2. One is when you take a plus, the other is when you take a minus. So your root 1, let it be alpha, your root 1, that's minus b plus under root b square minus 4ac by 2a. The second root beta, it is b minus b minus under root b square minus 4ac by 2a. Now the thing is, if your discriminant is less than 0, then both your roots are complex. Both roots are complex. Why am I calling them complex? Because this part, this under root part will be negative, right? So you'll have something like a root minus 2 or a root minus 1, right? Because the quantity inside the square root will be negative if your discriminant is less than 0. That means you'll have alpha as your complex root and beta also as your complex root. If your discriminant is equal to 0, then this part will be 0. So the roots will be minus b plus or minus 0 by 2a. That means both your roots are minus b by 2a, right? So if d is equal to 0, roots are same. And what are the roots? Minus b by 2a, right? If your d is greater than 0, then you have 2 real roots, because this under root positive quantity is a real number. So minus b plus or minus under root positive quantity by 2a. So it's simple. D less than 0, both roots are complex. D equal to 0, both roots are same and they are equal to minus b by 2a. If d is greater than 0, discriminant is greater than 0, then both your roots are real. Coming to sum of roots. So for this quadratic equation, what is the sum of roots? So your first root is alpha, second root is beta. If you add these two, this root b square minus 4ac part gets cancelled, right? And you'll have a minus b by 2a. So alpha plus beta, that will be equal to minus 2b by 2a or minus b by a. So minus b by a, or coefficient of x divided by coefficient of x square with a negative sign. That is what your sum of roots is. This is something that you would already know. Similarly, you also have alpha and beta in this form. You can multiply these two, and you'll get to know that your product of roots is given by constant divided by coefficient of x square, or c by a. So constant divided by coefficient of x square will give you product of roots alpha beta. Coefficient of x divided by coefficient of x square with a negative sign will give you sum of roots alpha plus beta, right? And the roots are obviously given by this formula. This was the basic understanding for quadratic equations which you already had. Let us quickly look at what will happen if your quadratic equation has complex coefficients. If your a, b, c are complex, nothing different will happen. So let me just clear some space for me to explain you here itself. So let this be your quadratic equation: ax square plus bx plus c, a, b, c equal to 0 obviously are complex, right? They are all complex numbers. Now the roots are simply given by, or I can say root 1 alpha is given by this formula, minus b under root b square minus 4ac by 2a, and root 2 beta is given by b minus b under root b square minus 4ac by 2a. As you can see, there is no change in the formula of alpha beta, just that from here alpha beta, you can get complex alpha betas, you can get equal alpha betas, you can also get real alpha betas, right? When your discriminant is greater than 0, you can get real alpha betas, equal alpha betas, or complex alpha betas. But here, if your a, b, c are complex, then you will only get complex alpha betas. So both these alphas and betas are complex numbers because your b, a, everything is complex, right? So your alphas and betas are complex. You don't have other cases, so you won't look at this discriminant. Discriminant here is also b square minus 4ac, but there are no signs that I will associate. Like I won't say discriminant greater than 0, equal to 0, less than 0. These I won't define for my discriminant because they are irrelevant. That information is not of any use to me. Both my alpha and beta, they'll always be complex because my coefficients are complex. But when coefficients are real, you can have complex both, you can have both real, or you can have both the same and real, right? All these cases are possible when your ABC are real. So with this, let's move on to the next subtopic.